Welcome back to the channel. Today we have 2026 Jan P3 walkthrough. It is Edmond. Don't forget to subscribe. All right, question 10, we have a modeling question here. We have two populations of insects are being studied. So the first model studied the number of insects N in population A after T years. The model is given by that. That's the first model. According to the model, find the rate of growth in the number of insects in the population at exactly 5 years after the study. I started the rate of growth. The rate of growth here, we are talking about the N, the T. Let us see here how to get N, the T. So our N is 8,000 plus 900 E of 0.2. That means the A, the T is equal to, this is a constant, so that goes away. So you have 900 multiplied by 0.2. We have already seen the derivative of exponentials times E to the power of 0.02. So the N, the T is equal to, so when you multiply, you have 180 into E to the power of 0.2 T. But they say they want the rate of change at exactly 5 years. That means T is equal to 5. So that means you have the T, the N, the T as equal to 180 E into 0.2 to the power into 5. That means when you press your calculator, you're going to get your final answer was 480 and 89. I have this answer here rounded. Part B, for the second model, we have NB, the number of insects. NB, the number of insects, as equal to 8,000 plus P e to the power of K, KT. So I have the first condition at the start of the study. We have at 10,000. It means that when T is equal to 0, at the start of T is equal to 0, this is what we have as our population N. That means 10,000 is equal to 8,000 plus P into e to the power of K into 0. That means you can see that 2,000 is the value of what? Is the value of P. Because this is 1, this power of 0, that is 1. 2,000 the value of P. That means your model now is NB is equal to 8,000 plus 2,000 e to the power of what? Of K, of KT. Now we have another condition here, is that after 4 years of the study, the number of insects is that. That means 11,570 is equal to 8. That's 1,000 plus 2,000 e to the power of K, and the number of years, which is 4, replace 4 over there, which is 4K. Now let us try to calculate this. So if you try to calculate this, you're going to subtract this onto the other side, and at the same time divide by. So all right, just write it here: 3,570 equals to 2. Guys, you can skip some of these steps here, but I'm writing everything because I'm trying to explain. So this is going to be 357 divided by, I'm cancelling some stuff out. All of this is equal to e to the power of 4 to the power of K. Now what we do, we take the natural logs on both sides. So ln of 357 over 200 is equal to 4K. So you can see the value of K is your ln of 357 over 200 divided by 4, and your K is going to be equal to 0.145. Here I've rounded it already to these kind of figures. When you press here, you can get the actual big number. This one is already rounded. Let us see the next question. I'm going to erase this. I go to the next question. Part C of the equation. Now look at this statement over here. The statement says that there are the same number of insects in the population of A and the population of B after T years. So we are finding the value of T at which all the populations are the same value. That means NA is equal to what? NA is equal to NB. That means we are solving the equation NA is 8,000 plus 900 e to the power of 0.2t, and this is equal to NB, which is 8,000 plus 2,000 e to the power of 0.145t. Remember, this is the value of k that you found in part B, and this is the value of p that you found. Now we are going to try to solve this equation. What I'll do, this one will cross out because they are the same value. Now just collect the like terms on one side. I'll bring the this is 900, 0.2e is equal to 2000 e to the power of 0.4145t. I'll cancel these two zeros, all right, so that I stay with 2 over 20, and then I have e to the power of 0.145t. Then I'm going to divide it by this, which is e to the power of 2t, e to the power of 0.2t. Then you do the math here, so you have your 9 over 20 equals to e, you join it. So when you are dividing, what do you do? You subtract, so you have negative 0.055t, and then you take natural log. So ln of 9 over 20 is equal to negative 0.055t. So your t is the ln of 9 over 20 divided by the negative 0.55, and then your answer for t is going to be 14.5. So your capital T is 14.5. Yes, that's your capital T. There's some steps you can do differently in this in all this process, but I'm just doing this because this is what I can see first. All right, thank you.